standard is going over. You've been working on using algebraic methods to evaluate limits by hand. So those are the 3 or 4 strategies we have: direct substitution, conjugate, factoring, and having fraction divided by fraction. The 4-type problems, the reason there are 4-type problems is because composite functions and ones where you have to factor a cubic are not as frequent, but they still come up sometimes on the AP exam. So even though there are 4 types, it would still be very good if you did your best to know these and practice these when I give you the opportunity to do it. So I think example 7 is our composite function. If you'll flip there. Okay. We're going to do an A and a B here.
There's 3 of them.
Now, these problems with composite functions are written more like a sentence of limit statements. So they say, all right, if you have the limit as x approaches 0 of f of x, and they tell you that that limit value is 3. This is a 4-type problem, yep. And the limit as x approaches 3 of a whole different function is 4. Okay, so they're saying, okay, these 2 limit statements are true. Do I know what f of x is? Like, do I know what the function is? Nope. Do I know what g of x is? Nope. Okay. But based on those 2 limit statements, I'm supposed to figure out what the limit as x approaches 0 of g of f of x is. It's not the transitive property, but it's kind of like the transitive property, where you say if A equals B and B equals C, then A equals C. That whole thing from geometry.
She does this really weird thing.
So with composite functions, we've talked about composite functions, and we'll actually talk more about composite functions when we get into derivatives, because we see them again then. But just to review, if I have, so I'm kind of doing another problem here just to remind us what composite functions are. If I said find g of f of x, and g of x I'm telling you is this, and f of x is this, what is this telling you to do with those 2 things? Plug x squared into the other function for x wherever you see x, right? So g of x would be 2 times x squared minus 3, right? Okay, we did those in Algebra 2. I think you even do them in Algebra 1 a little bit. But that's basically the type of function we're dealing with. When you find the limit of a composite function, they usually don't tell you what f of x is and then what g of x is. They don't give you those kinds of statements. So you can't just, figure out this part of it and then find the limit of that new function. You have to go off of the information they've given you. I want you to notice 2 things here. In this limit statement, the limit value is the c value of the next limit statement. So there's this little connecting piece between these 2. So I'm going to draw a little connection line there. The other connection line is that the original c value matches this c value now that you're finding the limit with this composite function. There should be things that link up because you're plugging these 2 functions into each other. So some stuff is going to overlap. So if the limit as x approaches 0 of this function is 3, and then they take that and use this as the new c value, and then the limit as x approaches 3 of this other function is 4, then the limit as x approaches 0 of this new composite function is 4. It's almost like they take the first c value and match it with the last limit value. So the answer to this is 4. Now, this is just a general, like, I haven't written out the whole property for you, but this is just a property of composite functions. That those things will always link up, and then your final limit value, if those things link up, will be the last limit value there. So, I'm going to do another one just to show you that the same link ups happen. So, if the limit as x approaches 1 of f of x is 5, and what would this new c value have to be for this next limit statement? It'd have to be 5, because those would have to link up, of g of x equals negative 7. If those two things are true, then the limit as x approaches, what would it have to approach? What was the other link that had to happen? 1 has to be approaching this original c value here, of your composite function is negative 7. That's all there is to it. And they aren't very common, but I have seen them on AP practice exams, where it's just a multiple choice problem, and they give you a limit statement like this, and they just say, what's the limit value? And you don't have to do any work for it. You just have to know that those links happen, and then you can say that it's the limit value of negative 7. So it's just a property, but it's one we have to talk about. Okay? Any questions on that? There might be when we can do some problems, but all right. And then the other type goes back to factoring.
Other type of photo.
Okay, we're going to look at the limit as x approaches 1 of x cubed minus 1 over x minus 1. I want you to make an A and a B because there's actually two different ways to do this problem. Okay, so there's actually two different ways to do this. Depending on which way you like better, you can choose either way because it doesn't really matter. First way we're going to do is factoring and dividing. Now, this is not a quadratic, so we can't just start with making two parentheses here. This is a cubic. If you don't remember, I might draw a little squiggly down here. This was one of the things, or one of the factoring patterns I made you memorize in Algebra 2, because it's the only way to really factor something that looks like that. This is called a difference of difference of cubes. Yes. So when you have a difference of cubes, you have a cubed minus b cubed, which is what we have here. We have x cubed, and then technically 1 could be 1 cubed. You can factor that using this pattern. A plus b times a squared minus ab plus b squared. The values for a and b are the cube roots of the two terms you have. And then the other one that we covered when we were talking about factoring cubics before was sum of cubes, which is just changing the sign in the middle, but again, both your terms are something that's being cubed. Yep. Yep. Thank you.
Oh my god.
I had them written in a different order over here. I was just copying without. Yeah. Because then here, yeah. Because here this would be a plus b, and then a squared minus ab plus b squared, because the things, or the signs change, flip-flop. So when you have a minus in between the difference of cubes, the minus should be in the first factor here. When it's a plus, it should be a plus here. So we're going to factor and divide. No, it'd be plus. Like, this is minus, and this is plus, and then this is plus, and this is minus. They just flip-flop between the two factoring patterns. All right, so for the factor and dividing of this here, we need to figure out what my a and my b are in order to fit it into the pattern. So a and b are the cube roots of both those. What's the cube root of x cubed? X. What's the cube root of 1? 1. So when I factor that, it would be x minus 1, because it's the cube root of both. And then a is x, so it would be x squared, plus a times b, which is just 1 times x, or x. And then b squared would be 1 squared, which is just 1. And then we divide by what's already there. So what cancels out? X minus 1. And then can I now use direct substitution? And if I use direct substitution, I get 1 plus 1 plus 1, which is 3. So we could say the limit as x approaches 1 of this function is 3. Now let's say you come across this problem and it's on the non-calculator part. So you can't use a calculator to figure out the limit, and you don't remember the factoring patterns, or you're not positive you remember it completely. Then the other way to do this type of problem is to use synthetic division. Does that ring a bell?
Oh, yeah.
Okay, so synthetic division, and I know this is a little bit of review. Synthetic division only can happen when you have x minus c or x plus c, when it's a linear factor in the denominator, which we have here. You take your c value, which in this case is 1. If it was x plus 1, then what number would go here?
-1.
A -1. And then we list our coefficients. My coefficients of the top are 1. And if you're missing terms, like we're missing x squared and x, you have to put a 0. So you have the x cubed term, the coefficient in front of x cubed is 1, then 0, 0, and this should be a -1. Okay. Does anybody remember what I do first?
We drop down the 1.
Drop down the first number, so we drop down the 1. And then we multiply. 1 times 1 gives me 1. And then do you add or subtract? You add. Good. So 0 plus 1 gives me 1. Then we have 1 times 1, which is 1. 0 plus 1 gives me 1. 1 times 1, which is 1. And 0. That number is called my, what? Remainder. Yep. And then we can rewrite this x squared plus x plus 1, because this number will be your just your constant. Then the next number to the left will be your x term, x squared. And then if you had other numbers going this way, it would be x cubed, x to the 4th, so forth and so on. And notice we're at the same spot we were here, because then you can directly substitute 1 in again, and you still get 3. I do not care what method you use. So you can use synthetic division to break it down to something that you can directly substitute into, or you can use the factoring and dividing method. Either one is fine.
It's just a 4 level because of the cube mechanic?
Yeah, because they're not as common, so they're not as essential that you absolutely are proficient at it unless you want to be. Yes, Sophie?
On the synthetic division, do you need to drop down that one or that one?
This first coefficient is what you drop down. Yep. Okay. So for the rest, those are the 4 type problems. I want you to go to your document.